Good day, everybody, and welcome to Grignard Analysis. We'll be looking at Grignard reagents, taking a look at the mechanism and predicting the products from a Grignard reaction, and then we'll be taking a retrospective analysis where we'll be looking at a product and thinking about ways to make it through a Grignard reaction. So first, what's the deal with Grignards? Well, what we're going to be doing is reacting a carbonyl, either an aldehyde or a ketone, with a Grignard reagent, something that has this MgBr on it. So, what's the MgBr do? Because the magnesium is very electropositive, it actually pushes electron density onto a carbon, effectively creating a very reactive carbanion. And what's this carbanion going to do? Well, it's going to react with the carbonyl. So let's take a look at the mechanism. The reaction itself is pretty straightforward. The carbanion from our Grignard reagent is going to attack our carbonyl. And then, in classic fashion, the electrons from the carbonyl from the pi bond are going to jump up onto the oxygen. So, what's this going to get us? Effectively, what this does is it creates a new carbon-to-carbon bond. Very, very important in the world of organic synthesis. So just for your reference, because these can look a little interesting when you're first looking at these reactions, this carbon here is this carbon here. While this carbon here, that was at our carbonyl, is this carbon here. Notice it's still attached to the oxygen. So just for your reference here. You'll notice that our mechanism, or rather our reaction, has two steps in it. So our second step is quenching the reaction through adding in hydronium. What this is going to do is effectively stop our Grignard reaction and give us a stable product. So we're going to add in our hydronium and then attack. And what's this going to do? Quench our reaction to give us our final product and water. So really pretty straightforward two-step mechanism. The carbanion attacks the carbonyl, and then we quench it. Now we're going to take a retrosynthetic look and look at how to make this particular product with three exciting combinations of Grignard reagent and carbonyls. Woo! Let's get to it. When looking at our product, everything comes down to this carbon here, where the OH is, because that carbon is the site of where one of the new carbon-carbon bonds was formed. So essentially, we're going to approach this from imagining three different scenarios. And probably the easiest way to imagine this is if you just make a cut immediately adjacent to the carbon-oxygen bond. So what I mean by that is, let's do one right here. So now what we're going to do is we're going to split the molecule into two pieces, a Grignard and a carbonyl. So the carbonyl had to come from, or had to be the precursor that ended up leading to the molecule with the OH on it. So let's see what that would look like here. At this point, I highly recommend counting out your carbons, or just using some as reference points. I'm not going to count all the carbons here, but what I am going to do is I'm going to number these carbons here to give myself a sense of an idea of how long this carbon chain is. So I see there's 7 carbons in this chain until we get to that benzene ring. So when I draw out the carbonyl precursor, I can use those numbers as reference points. So this looks about right. Now we have to add in the benzene ring. There we go. Okay, great. And then what we're going to do is at carbon 4, we can see that's where the OH is in our product. We are going to put our oxygen there. But since it's the carbonyl precursor, rather than being an OH, it's just going to be a carbonyl. So there we have the carbonyl half of the reagents that led to our product. Now let's consider what the Grignard must have looked like. We can see that on the other side of the cut we made here, there are 2 carbons that lead up to that cyclopentane ring. So let's recreate that structure right there. Now that we've done that, all we have to do to make this a Grignard is add MgBr. So now this effectively creates our carbanion. The MgBr again would push the electron density onto this carbon to make it react with this carbonyl site. Cool. Now, a great idea when doing this is always count your carbons. It's possible to lose a carbon or add a carbon, a phantom carbon somewhere along the lines. So the last thing I always do when doing retrosynthetic analysis is make sure that the number of carbons adds up. So in our Grignard, there's 6 carbons. In our carbonyl, there are 14 carbons. And in the product that we're trying to make, there should be 20 carbons, which indeed there are. This checks out. Now, let's look at another way that we could possibly make this product. But first, since we've done our check, cha-ching, we're good. So previously, we cut our Grignard our product right here to make our reagents. Instead of doing that, let's try cutting right here. Okay, so now let's envision what our reactants would look like. I always like to start with the carbonyl. So, again, I'm going to do some numbering for my reference. So there are 6 carbons spanning from our cyclopentane ring over to our benzene ring. So I'm just going to draw that backbone. So here we've got our 6 carbons. On the 6th carbon, I'm going to draw in an aromatic ring, like so. And on this first carbon, I'm going to attach the cyclopentane. Great. Now on carbon 3, we're going to put the oxygen there because that's where it is on our product. And then let's make this a carbonyl. There we go. There we have our carbonyl. Now our Grignard is going to look awfully similar to this right here. So we're going to recreate that. There are 3 carbons in our chain, and on carbon 2 we have 2 methyl splitting off, so let's just make that. Like so. And then we're going to add in our MgBr. And there we have our Grignard. Okay, so now let's count the total carbons in our Grignard and our carbonyl. We've got 5 total carbons in our Grignard and 15 carbons in our carbonyl for a total of 20. Woo! That is the number we were looking for. Okay, now let's try the final combination we could make for this one. This time we're going to make our Grignard carbonyl cut right there. So first let's start by drawing out our carbonyl. Okay, I'm going to make a 6 carbon chain. Okay, so there we have it. And then we're going to have to add in a cyclopentane on the carbon number 1. Okay, there we have it. And then on carbon 3, we're going to make our carbonyl. Cool. Up next, our Grignard. Okay, so we've got 3 carbons, and that 3rd carbon is the start of our benzene ring. So there we've got our 3 carbons, and then let's throw in this benzene ring. Great. And then finally, the coup de grace. We need to make this a Grignard, so we're going to just put an MgBr on the carbon that ends up forming the new carbon-carbon bond. Okay, once again, we're going to do our check. We've got 8 carbons on the Grignard. We've got 12 on the carbonyl. Hey, I don't want to alarm you, but we've got a total of 20. And that matches up with how many our product should have. So those are, in effect, 3 ways that we can make this Grignard product. So any one of these Grignard carbonyl combinations will allow us to achieve our Grignard dreams. All of these will get us that product. Okay, and thus concludes our Grignard analysis. Thank you for your time and have a great day.